All right, hello there, Trig students. This is our first day of doing any kind of online classes. Just using a new tool here that should help us make good videos that help us learn what we're supposed to be doing. And I apologize, sometimes when I mess with this tool, I am having some trouble with the audio, but it should be good enough for what we need to do. All right, we're moving into chapter 6 today, and you actually did a little bit of a prep assignment, just sort of barely dipping your toe into the idea of law of signs in order to get a handle on what we're going to be taking on today. But we're working on the first of two laws. There's a law of signs, and shockingly, there's a law of cosines that we do next time. So let's talk a little bit here about the law of signs. The law of signs is one of the ways in which what we've done so far in trigonometry connects to triangles that aren't right triangles. Trig is so much about what you don't think it was. I mean, everybody was expecting this class to be about right triangles, but actually it's been about circles and it's been waves. And now it's even going to be about triangles that aren't right triangles. And the right way we describe such a triangle is as an oblique triangle. So an oblique triangle is just a triangle that's not a right triangle. We're always going to label the three corners of the triangle with capital letters. And then the sides opposite of that will have the same letter, but in small case. So like over here, we have A. The big A will be the angle. Little a is the side opposite that angle. And that'll just be our terminology that we'll use when we're discussing these oblique triangles here. And over here, highlighted in orange, I have the two different forms of the law of signs. They're actually really easy to remember. It's just sine of big A over little a. Okay, let me make that more clear. Sine of big A over little a is equal to sine of big B over little b, which is also equal to sine of big C over little c. And this reciprocals all work in the lower form of that equation here. Little a over the sine of big A is equal to little b over the sine of big B, which is equal to the little c divided by the sine of big C. So any of these forms of these law of signs, I'll just keep using that same little piece of clip art I just made there that's highlighted in orange throughout the presentation, and I'll just highlight the pieces of the equation we're using at any given time. Um, as always, when we do the test, you're going to have it. It's going to be open book. But I think law of signs is one of those things that actually you can do without having the book right in front of you. And we can solve a lot of important types of problems involving triangles that are oblique using law of signs. What kind of problems are we talking about? Well, hey, you're going to recognize this terminology. We're going to do AAS problems, first of all. Remember that was angle, angle, side? Hey, remember in geometry we had different rules. They usually were rules about how triangles were congruent or similar and things like that. I think AAS was a congruent thing. Anyway, we're going to see how that connects to what we're doing right now in this class with regard to the law of signs. So I'm actually going to do example 1 from page 405. It's an example of an angle, angle, side application of the law of signs. This is, I believe, the problem that you did for the prep assignment, although there were different numbers here for these different angles and sides right here. So in this problem, though, they give us that big C. The angle big C is 102.3 degrees, and the angle big B is 28.7 degrees, and the side little b was, in this case, 27.4 feet. And what we're going to do here is try to solve for the other sides and the other angles. Well, actually, the other angle is A, and actually that was easy because it's just 180 minus the other two angles, right? Because we want the sum of the three angles of our triangle to be 180 degrees. So, okay, the big A was easy. That was no problem. Now we need to use the law of signs to get us to side A and side C in this case, so that we have all 6 pieces of information that we need for this triangle. And I'm giving you here another, just writing in here again, the law of signs. And well, actually, it's not too hard to notice that we have the middle term of this equation because we have both big B and little b in this problem already. Now, we could have had different information in the problem, and maybe we would have had big A and little a, or we would have had big C and little c. But as it happens, in this particular problem, we have big B and little b. So the middle terms of these equations we already have. So if we want to try to figure out what, for example, to solve for the little a, well, we'll just use the left 2/3 of the equations, and I'm highlighting both of them there because either one would work. Just can be easier for like how to rearrange the fractions and things like that if you use the top or the bottom. But in this case, we're going to work with one of these highlighted equations here, and we have big A, so sine of big A is over little a. We don't have the little a, equals sine of big B over little b. We have the big B and the little b. So actually, that's pretty straightforward there. And actually, you just do the arithmetic then, and it works out that A is 43.06 feet. Hey, that was pretty slick. And in fact, we could do the same sort of thing for C. Sorry, my phone is beeping like crazy. We could do the same thing for little c. I'll switch over to using the right 2/3 of the equations right there. Again, it wouldn't matter whether you use the top one or the bottom one. You'll get the same answer either way. Sometimes the fraction is just a little easier to work with one way or the other. And so in this case, we have big B and we have little b, and we have big C given to us in the problem. So we have everything we need to solve for little c. And in fact, in this case, you get little c is 55.75 feet. We have solved this triangle, this oblique triangle. We now have all three sides and all three angles. That's the kind of problem we need. These are examples of AAS problems, angle side problems, and they are always, okay, I'm going to say they're always easy, but they are always just plug and chug kind of problems. The only trick is knowing, is it an AAS problem? In an AAS problem, you're going to be always given two angles and one side of a triangle, and the side that you're given is not between the two angles that you were given. You can kind of get that actually from the name AAS. See how the S is not between the two A's in that name? That's actually kind of the giveaway. It's an AAS problem if you have two angles and a side in the given part of the problem, and the side is not between the two angles that you have. Okay, I'm not too worried about AAS problems. I think you're going to be able to do them just fine on today's project. But AAS problems are only one type of problem that we're working on. Another one that we can use with the law of sines is the ASA problems, angle side angle problems. Again, that terminology is probably something you vaguely remember from geometry. And in fact, they're very related ideas here. I'm actually going to do example 2 from your book on page 405. It's an example of an angle side angle problem. It's a little bit of a story problem. In the story problem, there's a pole that's leaning. It leans 8 degrees from the vertical. So like what they're trying to say here is if we had some triangle here between that pole and the ground, that angle would be 98 degrees. Okay. And that pole has a shadow casting on the ground. I didn't draw it very well in PowerPoint. If you want to see a better looking picture, look at page 405 in your book. But that pole has a shadow, which in this case is 22 feet long. All right. The problem gives us that that's how long that is. And then it says that the angle between like the tip of the shadow and the top of the pole there, the line that I have drawn in red, is that angle there is 43 degrees. So the problem is giving us two angles and one side of a triangle. This is an angle side angle problem. Side is between the two angles that we're given. All right. Law of sines is going to be the right tool for the job. Here I have in red drawn the triangle we're working on. We'll call that 98-degree angle over there. We'll call that A. And we'll call that 43-degree angle B. And we'll call that one side there that we got side C. And we'll call it 22 feet. And the problem is actually asking for us to give us the side B of the triangle. That's the length of the pole itself. That's side B of our triangle. So we don't have to solve the complete triangle here. We're just doing that. All right, so I'm putting up here again a form of the law of sines up there. And let's see what we can do with this thing. Well, we're going to need the angle C, but that's easy because we have the other two angles already, and we just need to make them add up to 180. And you just do a quick arithmetic there. And it turns out that angle C is 39 degrees. So now I can plug, let's see, like I highlighted the right 2/3 of those equations there. We've got big B, we've got big C, and we have little c. So actually we have everything we needed except so we can solve for little b. No problem. We can use either the top or the bottom equation. They're the same. And I mean, they work out the same. Neither one's better than the other. Great. And in fact, these angle side angle problems are always easy. They're not necessarily easy, but they're always plug and chug. Okay, let's put it that way. The third type of problem we're going to learn about today is not always just plug and chug. So how do you know if it's going to be one of these relatively easy angle side angle problems? Well, you're always going to be given in the problem, if the problem has two angles and a side, great. And the side that you're given is between the two angles that you are given. All right, that's how that problem with the pole was, right? The side that we were given was the 22 feet that was the length of the pole. I'm sorry, it was the length of the shadow, and it was between the two angles that we were given. That always makes it an angle side angle problem. And the angle problems don't take any real, like, you don't have to do a lot of thinking or something. It's just a matter of getting all the information into your calculator carefully and working it all through. So we've learned about two kinds of problems you can solve with the law of sines, but there's a third one, the side-side angle problems. Okay, these are the ones. Hey, wait a minute. You might be thinking, wait a minute. I don't remember in geometry learning about SSA ever. Yeah, it turns out there isn't a SSA rule for like congruent triangles and things like that you might have learned about in uh, geometry. But it does exist in Trig for this application, but it is what's called the ambiguous case. You're going to see there's actually 6 different possibilities as to how this can work out. The good news is you're not on this assignment actually solving any SSA problems. Rather, you're going to be you're going to be figuring out how many triangles are possible of the 6. I actually have taken this figure from a different website here that summarizes the 6 different SSA rules, the different ways we can determine whether or not we can and can't solve a particular oblique triangle. That I taken this from a different website. That your book has almost exactly the same table though on page 406. It's just organized a little differently. Where this guy's rows, I think on the book it's columns, but it's the same thing. And I certainly would suggest that you go to page 406 right now and kind of be looking at that figure as we go along. So there are 6 different possibilities with regard. If you have an SSA problem, you have 2 sides and an angle of the triangle is what's given to you. There's actually 6 different ways the problem can play out, summarized by these 6 different lines here. And what you do is you start off with a question. The problem's always giving us one angle. We're going to call that angle A. All right. So if you have to rearrange the letters on your trig on your triangle, that's fine. Now, I want you to then think about that angle that you're given. Is that angle big A acute or is it obtuse? Remember acute and obtuse, they were, whether it was less than or greater than 90 degrees. All right, so that's the first question. That's like what this column here is in the table right here. You have to decide if you are in one of the rows here for obtuse or whether you're in one of the rows for acute. Again, I think in your book it's the other way around. I think the acutes are columns and then the obtuses are columns, but it's the same sort of idea. It's the first part of the table there. All right, so let's just do the obtuse rules first. And to give myself some room to do some work here, I'm going to actually cut out the middle part of that table. And so all we have now are the 2 obtuse possibilities. So there's basically 2 possibilities here. You know this angle A, big A, and you'll always know the side opposite A, little a, on a triangle in an SSA problem. And then there'll be another side. I mean, it's SSA. There's 2 angles on a side. So you've already called one side A. Let the other one just be called B, little b. Okay, so you've got the angle A, the side opposite is little a, and the other side that you've got, whatever that is, make that little b. All right. Now, you just need to try these 2 different obtuse rules. You have 2 different criteria here. If A is less than or equal to B, well, it turns out there's no possible triangle. There is no way with that information of that angle and those 2 sides. Turns out that book actually tries to draw a diagram. This website I used actually tries to draw a diagram. There's no way to make a triangle. They have a shape here that's made of these lines, but they don't fit together to make a triangle. That'll happen if A is less than B. If A is greater than B, then in fact there is one triangle that will happen. You could actually draw it, it would make a triangle, and you can just go ahead from there and apply the law of sines to the information you got, and you would get the problem to solve. There would actually be a triangle with a real number of degrees that makes that has real lengths to its sides and all that kind of stuff. There's no nonsense of imaginary numbers or anything like that. So the obtuse rules. Hey, wait a minute. Am I going to have to memorize all these? Of course not. You've got page 406. Get yourself a paper clip or a bookmark or something. Just mark that page for that table because it's easy to make mistakes on there. Then what if the other four rules are what we need? What if we're talking about a situation where that angle A that they gave us, that big A, was an acute angle? All right. If you are on one of those acute, if that angle that they give you is acute, it's worth your time to right off the bat first compute this quantity H. H is just B sine big A, and you have B and you have big A in this problem here. I'm going to make my phone go to sleep here because this is ridiculous how many messages I've gotten in the last few minutes. And there we go. All right. H is actually the height of the triangle, if you remember that term from geometry or grade school or something like that. And that H is going to be useful when you are applying the SSA rules for an acute triangle, for an angle, when the angle you're given rather is acute. So I'm going to just trim to make myself some room here, and I got rid of the obtuse rules here, and I'm only showing the acute rules. Again, on this particular version of the table, the acute rules are in rows, but in your book, that's actually in columns. Like the top line is acute, and then the next line is the test, and then the next line is the number of triangles, and then there's a drawing where they're trying to show you how to make it work. Okay, it does the same sort of thing. All right, you have four possible acute rules. If rule one, if A is less than H, you remember I took a moment here to compute H, but A was something given to you in the problem. If A is less than H, it doesn't make a triangle. I actually tried to show you that up here. The pieces don't fit together to make a triangle. There is no triangle with those lengths of sides in that angle. Okay, then the problem's done. Second possibility, if A is equal to H, well, then in fact, there is a triangle as possible. You could go ahead and apply the rule of sine, the law of sines to the problem, and you could solve for A, B, C, and angle A, angle B, and angle C. It won't be a tremendously exciting triangle because it's actually a right triangle, but it would work. You'd have a couple of places where you have like the sine of 90 degrees and stuff, which wouldn't be so exciting, but it could be done. So those are your first two rules. There's also, again, two more acute rules. There's a total of four here. If H is less than A and A is less than B, in other words, if A is between B and H in terms of its length, well, that's the tricky one. Then there's actually two different triangles that could be made using those sides and that angle that's given. They're trying to illustrate that here. You could kind of think of it as that one side could swing to two different positions here. The important thing to know is that there's two different triangles that would work. You could actually sketch it and see, oh, look, actually this triangle would work, but so would this triangle. For the purposes of the assignment today, all you're computing when you do these side angle problems is you're computing the number of triangles that are possible. So for now, we don't need to get worried about how you would actually work that one out with law of sines. And then finally, there's the rule 4. If the A that you're given in the problem is actually greater than or equal to B, well, then once again, you have only one possible triangle. In fact, you get this really big, wide kind of what's it called, an obtuse triangle or something like that. You would get but there's only one. And as long as there's only one solution, your law of sines will work just fine. Go ahead and start plugging numbers in. If there's no triangles possible, don't waste your time. You're not going to get real numbers for like the lengths of the side. And the possibility of it having two triangles gets complicated as how you figure out what those two triangles would be. And we're not doing that on this assignment. Again, do you actually have to memorize all these rules? Of course not. They're on page 406. Get yourself a paperclip or something and mark that page because you don't have to memorize that stuff. Let's just do a quick example of a side angle problem. All right, so if I have a triangle here and I've given in this problem that I have little a, the length of that side is 22 meters or whatever the units are here, and side B is 12 meters or whatever the units are, and our angle big A was 42 degrees, find the remaining side and angles. All right, well, let's first just figure out if we can even do this. Are these, it's a side angle problem, SSA. And if we have a side angle problem, how do I decide it's side? Well, I've given two sides. That makes sense. If I have that, then my angle A that I'm given it's acute. It's less than 90 degrees. Okay, so we're going to use the acute rules. We've got that list of four possible rules here. But remember, the first thing that's helpful here is to actually compute H. H is the height of this triangle here. If you remember from geometry, that's like connecting C down here to the bottom. H is, in this case, it's B times the sine of A. So B, which is 12 times the sine of A, and you get like eight units long. Okay. Then you work your way through those rules. And if you, I didn't have pull them up here, but you can go back through those rules over here. And it's the fourth one. A is actually greater than B, which means there's one triangle possible. A is greater than B, so there's one triangle possible. Zip back over here. Actually, that's the only one of those acute rules that we actually wouldn't have needed the H, but it was worth it just to do an example that showed us computing the H. Well, we just had to test the different rules and see which of the four rules applied. All right, so in this case, the fourth rule tells us that, let's go back and look at the fourth rule. There's one possible triangle that describes this, that matches this. There's one possible triangle we could draw that has a side that's 22, another side that's 12, and the angle that's not the one between those is 42 degrees. There's only one way we could do it, and the law of sines will work fine. We just plug in the numbers here, and like, for example, on this way I've written the law of sines there, in the circled part there, we know little a and little b, and we know big A. So we have everything in the circle part to get big B. And then once you have little a and little b, it's easy to get C because they just have to add up to 180. I mean, this is actually kind of getting to be a pattern here. Once we put these together, they're not so hard. And then when we apply our law of sines, we could also get then little c. We could go over here and get that other angle by using the right two parts of the equation. And we've solved the triangle. We now know all 6 pieces of information, the 3 angles and the 3 sides. This should work just fine. I put on here that I want you to actually work through example 5 on page 407 yourself. It's the example of the way that it shows just that the 2 triangles are possible case. When the rules were such for an acute angle on an SSA problem, and that there's actually 2 triangles. It's worth looking through that there, but we're not going to be solving any of those problems, certainly not for a very long time. That's by far the most complicated situation. So we can come back to that when the time comes. But if you want to look through it and start understanding what we're doing with that, you'll be fine. I want to also draw your attention to something that we're skipping for now, but that we will come back to. Another way of writing the law of sines is a way of getting the area of a triangle. Now, you learn how to do the area of a triangle like in 3rd grade or something. It's 1/2 the base times the height. But that's neat how that's done. But in practice, that height is one side times the sine of the angle kind of thing. This is just 3 different ways to really write 1/2 base times height. Now, if we were actually going to like really religiously go through the book at this point and solve these problems here, there would be a section of problems in today's assignment that uses this formulation. But as it happens, a little later in this chapter, they're going to introduce a couple other ways to compute the area of a triangle. And then they spend a bunch of time comparing them to how this way works. So we'll come back to see this formula for the area of an oblique triangle, in a couple days. And so for now, I just want to draw your attention. That's another way of saying law of sines. It's equivalent, but that's not what we're going to do right now. So what are we going to do for right now? Well, we're actually not going to do any kind of homework out of the book today. I have another one of those online interactive type assignments, this time set up a little bit better for you over on Ivy Learn. I'm going to show you how to do that in just a little bit. And then there's also an exit ticket about this stuff. And that's all due on Wednesday. Okay, so let me just show you what this looks like. I'm going to go over here to my tab where I am up in Ivy Learn here, and I'm actually in the student view right here. And in the student view, you can see chapter 6 has now some activities that are available. In fact, there are 3 activities: law of sines AAS problems, law of sines ASA problems, and law of sines SSA problems. And when you actually go there, each of them only has 5 questions. And they are like we've done before, where they are randomly generated problems. It picks the numbers for you randomly. Now, when you go over here, Like now, these are all going to be AAS problems. The good news about AAS problems is they always work. You don't have to do any business of looking at a table or anything. These are just going to be law of science problems. So here's a triangle. It's telling you in this case the angle big A is 44 degrees. Angle big B is 44. Angle big B is 43. And the length of side A over here is 6. Then what is the length of side B rounded to 2 decimal places? Okay. It's just a law of science problem. You've got 2 of the pieces of information and 3 pieces of information, and you use it to find the 4th one. All right. They're not very difficult. You go in here. You do need to write it to the right number of decimal places. And everybody's problem is going to look different here. So like I got 44 and 43 this time, but next time you do it, it's going to be slightly different numbers or whatever. And there's 5 problems here. And if I remember right, all of them are basically just exercise. Now, are you going to get them all right the first time? Maybe. But if you don't, you are welcome. No, you are encouraged to do them as many times as you need to. I'm going back out of here until you get 100% on those 5 AAS problems. When you get them all working, go do the same thing for the law of science, the ASA problems. So we're going to just show you real quick here what this is going to look like. You're going to go take the quiz on the ASA problems, but it looks exactly the same sort of thing. It's the same setup of a triangle. And this time I'm giving you angle big A is 43 and angle big B is 53. And side C has a length of 2 units. What's the length of side A? And again, you're just going to key it into 2 decimal places. Make sure you do the rounding right. Make sure your calculator's in degrees mode, all that good stuff here. And will you get them all right the first time? Probably not. And if you do, that's fantastic. If you don't get them all right, you can do these 5 problems. Each time you redo it, it's going to give you different numbers. You can do it as many times as you need to until you get all 5 of them right. All right. And then finally, there is these SSA problems, which could be horrible, but that's actually not what we're doing with them right now. All you're doing with these here is it gives you the information about the triangle. It gives you 2 pieces, 2 sides, and 1 angle. How many possible triangles are there for this combination of A, B, and big A? Your answer is either a 0, a 1, or a 2. So you're going to look at this information. You'll have to decide if you think this angle A is acute or obtuse. If it's acute, you'll need to compute that little h. H, remember, is the height of the triangle. And then there's those 4 different rules to compare it to figure out, oh, that works out to there's 1 triangle or there's no triangles or whatever. So you don't actually compute the properties of this triangle at all. You don't compute its sides or its angles or something like that. This is complicated enough for what we're doing right now. All right, so again, these right here, you can do as many times as you need to until you get 100% on it. There's no reason I won't be entering everybody gets 100% on this assignment because you can do this as many times as it takes until you can do these guys easy. I have it in my notes from previous semesters that the only thing people didn't like about this assignment is a little fussy. I mean, you have to be careful about your rounding and all that kind of good stuff. Keep the digits, keep everything to several digits, and then when you're done with it, you got the final answer for side B or whatever, enter it, rounded to 2 decimal places, and you should be fine. All right, so you have those little questions right there, and there's also a short exit ticket of some examples of this, and therefore you have some ways to get some feedback on this problem set. All right, I think that's all that we need to do to show you this. If in a classroom, we would now spend the rest of the period working. Remember, we are doing everything we can to make this as much like being in the classroom as possible. If you have questions, please email me or text me. And take care of yourselves, and I'll have a new assignment ready for you on Wednesday.